The next problem is you have to find the inverse Laplace transform of x of s is equal to 1 divided by, so x of s is given as equal to 1 divided by s square plus 2s minus 8, and the region of convergence is given. You have provided with 4 region of convergence, that is in these 4 cases you have to find the inverse Laplace transform. And now we will see, when you try to find the inverse Laplace transform of these in these 4 cases, you can see they are different. You are not getting a unique transform for this particular signal when the region of convergence changes. So first we will see what is the partial fraction expansion of this particular function x of s is equal to 1 divided by s square plus 2s minus 8. See, this particular uh, uh, denominator s square plus 2s minus 8 can be directly factorized as s plus 4 into s minus 2. So you can write it x of s is equal to a divided by, I am writing s minus 2 here, plus b divided by s plus 4. See, you can write a divided by s plus 4 also, that is okay. Now I have just written s minus 2 in the beginning and s plus 4 next. So now we will find the value of a and b. How will you find? A will be equal to s minus 2 into 1 divided by s plus 4 into s minus 2 at what is equal to 2. Now what will be the answer for this one? So s minus 2 and s minus 2 will get cancelled. So 1 divided by 6 will be the value of a. Now b will be equal to, the denominator for b is s plus 4 into 1 divided by s plus 4 into s minus 2 at s equal to minus 4. So these two get cancelled. S minus 2 term is here. So it will be equal to what? Minus 1 divided by 6. So a is equal to 1 by 6 and b is now equal to minus 1 by 6. Now your Laplace transform becomes x of s is equal to 1 by 6 into 1 divided by s minus 2 minus 1 by 6 into 1 divided by s plus 4. Okay. Now we will see the first case. In the first case, ROC is given as minus 4 less than real part of s less than 2. Now from the property of this from the property of region of convergence, when region of convergence is lying in between two poles, that means here if you try to draw the real part of region of convergence, you can see this is between 2 and minus 4. So you are actually getting a strip. So when it is a strip, means it has to be a two-sided signal. So this is a two-sided signal. So you have both u of t and u of minus t coming in the signal. So you know u of t and minus u of t is coming. Now is it for this particular term or this particular term? We don't know. So first you just write the transform inverse. That is, if this is s minus 2, so 1 by 6 into e raised to 2t will come, minus 1 by 6 into e raised to minus 4t should come. Now whether u of t is coming here or u of t is coming here, that we have to see. Now again, from the property of property of region of convergence, you just if the ROC is right of the rightmost pole, it will be a right sided signal. To the left of leftmost pole means it will be left sided signal. So you just find ROC is lying to the left of 2 and to the right of minus 4. So this minus 4 is considered to be the signal which is right sided signal, and 2 is considered. 2 is corresponding to the signal which is a left sided signal. So here 1 by 6 e raised to 2t will be having the term uh, u of minus t, and this will be having the term u of t. So this is the inverse Laplace transform in the first case, that is when the ROC is a strip. Now second one is ROC is given as real part of s greater than 2. So again you will write down the x of s. X of s is what? X of s is 1 by 6 into 1 divided by s minus 2 minus 1 by 6 into 1 divided by s plus 4. Okay. So x of t, again it is the same thing, e raised to 2t will come here, minus 1 by 6 e raised to minus 4t will come. Now you have to draw it and see. This is coming like this, no? 2 and minus 4. So this is 2 minus 4. Now here the ROC is given as to the right of rightmost pole. R real part of s greater than 2 means ROC is to the right of rightmost pole. So according to the property of region of convergence, if ROC is given as right of the rightmost pole, then it is a right sided signal. So right sided signal means it will be u of t. Now third ROC is, in this ROC is real part of s less than minus 4. So again you write down x of t is equal to 1 by 6 e raised to 2t minus 1 by 6 e raised to minus 4t. Now you draw the ROC. So it is coming as what? This is 2, this is minus 4. ROC is to the left of leftmost pole. So this particular signal is a left sided signal. So u of minus t will come instead of u of t. U of minus t should come. Then last case is, fourth one is given as ROC is given as 2 less than real part of s less than minus 4. Now this particular case, this is 2, this is minus 4. Now real part of s 2 less than 2 means it should be here, and less than minus 4 means it should be here. Two less than sorry, this is wrong, no? This is wrong. This is given as 2 less than real part of s less than minus 4. So 2 has to be less means real part of s is greater than 2. So in the first case you do, this is real part of s. Second case is minus 4 less than minus 4 means this will be coming here. So you don't have any region which is overlapping. So for this particular ROC, inverse Laplace transform does not exist. Inverse Laplace transform does not exist. So this is how the inverse Laplace transform will vary with respect to the region of convergence. For different region of convergence, you can see this particular inverse Laplace transform is different. So that's why we always say that when you perform the Laplace transform of a particular signal, you always have to write the ROC along with the transform. Otherwise you will not be able to find or able to identify the correct time domain representation of the signal.